G'day everyone and welcome back to the channel. I am continuing on with these boards. So without further ado, let's get into it. I'm going to just grab some components out this bag. I'm going to start with the LEDs for the current sources. Yummy current source. I like my current source. Current source goes well with a lot of different things. So the way this works is the LEDs go here, two resistors go here, the capacitor goes there, and then a jumper to the rail. So the LED's actually got to sort of go between this outer rail and there, so it needs to be spread a little bit. I think that'll do. Basically like that. Yep, that's actually perfect. I don't know how I got that so good. Wow. Alright. I think I'll just make up one current source. No, you know what? I'll do component by component. I'm trying to think of what's going to make more sense to me, but also I want to do it in the quickest method possible because I don't want to spend my time going backwards and forwards. So I'll just do component by component. That goes pointing in. Don't know why I've got this board in front of me. That was weird. Oh yeah, I need to spread the legs first. That sounds funny. Spreading the legs of a light emitting diode. I don't like the fact that they're like right next to each other. I want just a little bit of clearance. That's better. All right, that's two LEDs. one of the things I want to experiment with after this is up and running and I'm experimenting is the current sources. I want to try and compare a single transistor current source against a single transistor current source with an external reference against a single transistor current, two transistor current source. So that'll be interesting, because if you think about it, with an external reference, no matter what the supply rails are doing, the reference is not going to be going up and down, right? And I'm interested to see in an amplifier what has a greater effect sound-wise. Is it, having a more stable reference for a single transistor current source, or having a more accurate two transistor current source? Also, I haven't really thought about how accurate a single transistor current source can be with an external reference. It's probably going to be a lot more accurate with the reference not going everywhere. So yeah, got a bit of experimenting to do there as well. Like I said, what I'm trying to do here is build an amazing amp, just go all out on it, and then I want to do a lot of different tests and see, how much further I can take it and what can be done. I just have to find a way of doing this in a manner that doesn't consume my entire life. Oh, you gotta be shitting me. No way. I've put this LED in the wrong way. I just checked the others too. They are the right way. It's just this one. Yep. Good enough. Did I just melt a hole in the bag? Yep. All right. That is the LEDs. Well, for one board. What the hell, I might as well just do all one thing at one time and then move on to something else, eh? Kind of makes sense. No. You've got to be kidding me. You have got to be shitting me. My cat, oh my god, you guys are not going to believe what this cat's just done. 1, 2, 3, 4, 5, 6. Fucking asshole. Oh my god. I was in the middle of exporting a video in DaVinci Resolve and the cat's just cancelled it and mucked up my program. This is annoying. Sorry guys, I'll be one sec. Alright. Stay off of there. Sorry about that. I was literally looking at it a minute ago going, it's only got 40 minutes to go. Yeah. It's going to be a lot longer than 40 minutes now. Although I don't know if it'll be any quicker because half the file's already written. Probably not, since it's going to be exporting live encoded data. Talking like an American. It is late, it's like almost 3 o'clock in the morning. Not quite sure what that has to do with me talking like an American, but it's my excuse, and I'm sticking with it. I think I'm just going to do these LEDs and I'm going to go to bed. I am getting tired, and I don't want to make any mistakes on this. I don't have room for mistakes in this build. It's just too many expensive components, too much power, too much time. You know, if it blows up because of any reason other than me putting it together wrong, I won't be so upset. But, you know, if I turn it on and it goes pop because I did something stupid, like forgot to make sure the BIOS is working before turning it on, or hook up the PNP drive to the NPN drive or something like that, you know, I'd shoot myself in the foot. Don't know what happened there. That's better. The last 2 LEDs. That was so weird. I couldn't work out why I couldn't push the LED down for a sec. It's, you know, at the bottom of the plastic on the LED, it's got a little lip that runs around the base. Well, the bottom of one LED was resting on the lip of the other LED, and it wouldn't go down, and I couldn't understand why until I realised. Alright, well, that's the LEDs in on both boards. I think the next thing I'll do is... Actually, that's something I need to think about. The 5.6K resistors there for the current source. I think I'm going to go with metal film. Yeah, I'm going to use metal film there. I'd hate for any sort of noise problems to end up in the base of that transistor. I doubt you'd actually hear it, but still. What did I pick? Ah, it looks like I picked carbon for that. Alright, so I decided what to do. Can you guess? There's a hint. So I thought about it and I thought, well, I want to minimize inductance and I want to minimize resistor noise. One resistor does one, the other does the other. So then I thought, well, which resistor location is what more important in? Well, the top resistor noise is going to be more important because it goes straight in the base of the transistor. The LED was chosen for low noise too. The bottom resistor, it goes into a capacitor, so noise would be shunted through the capacitor for one. Secondly, the inductance of this resistor is just between the 0-volt rail and a capacitor, whereas this one is in between, well, this point here and the base of a transistor, and also a rail via an LED, which is where the transistor gets its reference point from. So I feel the top resistor is more critical for noise, the bottom resistor is more critical for inductance. Yeah, that's what I meant. So that's what I did. I used a 5.6K metal film for the top resistor and a 5.6K carbon film for the bottom resistor. Yeah, you can call it wank. It's up to you. That's just what I've decided to go with. I mean, look, here's the thing. I'm trying to build the best amp that I can build, for one. And for two, I've got all the parts on hand. So it's really no difference to me whether I use one or the other. The way I see it, I might as well just use, the best possible parts in their appropriate locations. So that's what I'm doing. If anyone's wondering how I'm managing to solder with my soldering iron, just with the very tip, well, one, it's a good tip and it's clean, but no, the main reason is because the temperature's set at 370, so it's fairly hot, so it's able to transfer heat over a distance with a small surface area. The other reason I've got it set at 370 is so I can solder stuff really quickly without having to keep the heat on the component for too long, but I still have a really good joint. Alright, now for the metal film resistors. Don't worry if a couple of the color bands on the resistors look a bit different, like the 5.6K multiply band doesn't look brown on two of them. It looks a little bit more like a dark brown or a red. It's still brown, it's just a different batch of resistors. Some of these blue metal film resistors can be quite hard to read the colors off of them. I mean, I don't personally have a problem myself, but I always have had outstanding eyesight. You know, a lot of people don't, and I commonly hear people complaining about these resistors. Even if I'm not in a well lit room, I'm probably going to want to take it to the light to look at it and, you know, double check what color it is, because if you're not in a really white bright light, you can get the colors wrong on these, especially when they sort of misprinted, which they do a lot. They will have like a brown at the end and then a different shade of brown in the middle of it, and that'll confuse you because you're not sure if it's supposed to be brown or red, and then red will look exactly the same as brown half the time. It's just, yeah, even if you've got good eyesight, they can be quite annoying. And you can't think that you've worked it out because every batch it changes again. So yeah, you just got to be really careful, especially if the resistor's doing something critical. After these resistors are on the board, I am going to bed because I am so tired. I said I was going to go to bed literally an hour ago, and it's 3 o'clock in the morning now. Before, when I said it was almost 3, it was like 2 something. Now it's 3:04. It's been at least another half an hour, 40 minutes since then. I get carried away on this stuff, but I do have to stop myself. And if I don't go to sleep tonight now, it's going to screw everything up for me, because I was doing even worse than 3 o'clock, which I'm not going to make 3 o'clock already because it's just gone 3, but I need to make 3:30. I'm trying to get my sleeping patterns moved forward, and if I don't go to bed a little bit earlier every night, well, I'll just be back to the start, won't I? it's starting to look like something. Although to tell you the truth, with how many transistors are on this board, it was already starting to look like something just when I got those done. But yeah, no, that's cool. I am starting to like the look of this quite a bit. I'm very impressed because I take pride in my stuff, I sat there and tried to make everything as symmetrical as possible so that all the resistances between all the traces were equal. I've tried to lay everything in stages so that there's no crosstalk between stages and channels. I've left good spacing. I've made the tracks thick so that there's really small inductance. Yeah. So I'm happy that it's coming out nice and it looks good. Anyway, that's all for tonight. I need to go get some sleep. I'll be back in the morning. Alright, my lab computer's still got 10 minutes to go exporting a video, and I want to shut it down instead of leaving it on, so I'll just work for another 10 minutes and then I'll go to bed. So what's next? Next is 47 microfarad capacitors. I'll do a quick test on these because I'm quite suspicious of them. Especially when they're Chong X and the spelling's not even right for Chong X. I had a feeling this was going to be the case. Okay. Let me just get another cap, a good 47 mic cap that's at least a reasonable voltage. Do I have one here? Okay, I got 4763 volt. I guess that's just over half the voltage. Let's see what the ESR is on this. This is a smaller cap too. Okay, 1.8. I guess that's not too bad then. Alright, well, we'll use them. The dissipation factor was fairly low on them for a little electrolytic too, so alright. Actually, truth be told, that's something I don't know. See, when I ordered those 400 microfarad music caps, bipolar caps for audio, for this, the reason I only ordered 4 is because I don't know if the dissipation factor's usually lower in larger caps or smaller caps. So I'm going to find that out. And I'd imagine, I've got to get these ready. I'd imagine it's got something to do with the voltage rating too. So I'll be finding that out in about a week, 5 days. So these caps, honestly, they could go here or here, but I'm going to put them there. So yeah, positive facing up. All right, I'll just bend all their legs out. The good thing is, even though I'll be swapping some components, because of the way I usually make my circuit boards like this, where I solder everything from the top, when I remove components and put them back in the box, they will just get used in another project because they will just mount straight down to the board as they are. So they never go to waste. These have steel legs, I'm not happy about that. But like I said, I've got proper nice ones on the way. Hey, there's one missing. Oh, it's over here. All right. Yep, that works nicely. I think before I put these in, I'm just going to do a quick sanity check, make sure all these LEDs are on the right way. That board is. And that board is. Cool. Alright, I'll get these tinned up. Alright, they're all tinned up. I think I'll orient the board on an angle like that. Start with the top pad. Yep, that works good. I've just got to be careful because these actually go over another trace. Alright, well that's 2 in. It's definitely easier to solder one completely in when I can still get to the leg. I mean, I could get to it from another spot, but I think this is the easiest way. Alright. That's them in. Alright, I'm going to do the other board now, and then I'm going to go to sleep because my computer's finished doing what it was doing. Now even the boards are starting to get some weight to them. That's a nice sneaky little spot to get to it from. Had a bit of trouble getting that lined up with the pad. It's on it now. Right. Like I said, there's a trace that runs underneath them, so I've got to be careful that one of the legs can't short onto that trace. Last 2. Alright. I'm happy. So all that's left to do now is, let me just double check. Wait a sec. Oh, I've actually forgotten something. Okay. That's not good. I don't know what I've done. something about this just doesn't seem right to me. I've got too many pads in this area that just don't have anything on them. I know I still got to put my fast transistor resistors in. 68 ohm, 47 ohm, and 2.2k. Where goes there? Emitter collector base. What? Oh, that goes to the output of that stage. Okay, that's supposed to be a pad. Yes, the collector's supposed to be a pad. That originally was going to go to a resistor and then to ground. Now it just goes straight to ground. Yeah, actually, that's all correct. What do you know? Cool. All right, I'm going to go to sleep. I guess in the morning I'll come in and finish off the VAS stage. There's a couple of resistors I've still got to fit. What else is going on here? We've got to put a link from there to there that goes to ground. I should have run a trace. I don't know why I did that like that. Oh yeah, because I was going to star ground it, but it doesn't really matter. I'll think about that tomorrow. Alright, I'm going to go get some sleep. Alright, continuing on with PCB construction. I've just decided that because I used those 5% carbon film resistors on the top and the bottom of the input section, I just want to see what the actual resistance is, because if they're actually off, I'll go through what I've got and get them matched, because there's no point in having the transistors matched and then having, 5% tolerance resistors. 66.4. Yeah, nah, not happy with that. 46.5. 46.2. 46.8. Yeah, I think I'm going to change them. I don't know if it's actually going to make a difference, because if you think about it, one side which runs off one resistor at the top and one at the bottom is for negative feedback, and the other side is for the input. But I would think it does, because the two sides sort of teeter-totters, if you know what I mean. So for it to do that accurately, both sides would need, the same resistance essentially. But then when you use offset adjust, you're trimming a resistor at the bottom. It's interesting. I think I'm going to leave that, because one of the things I'm going to do when I get this amp up and running, one of the tests, is going to be experimenting with different resistor types. So I'm curious to see if lower value resistors in the input section make any difference at all going between metal film and carbon for noise. And same thing with high value resistors, because there's only a small current in the input section. I'm wondering how much inductance affects it, if any at all, as well. So I think I'll leave it for now. It'll be interesting to see what sort of difference on an analyzer and the scope and all that sort of thing when I get an analyzer, scope tool then. It'll be interesting to see what difference there is between having high precision resistors in there versus ones that are a bit off. Also carbon versus metal film. So yeah. I'm just going to pause the video and have a think about it. But I think that that's the route I want to go. Just leave it how it is for the moment. I might, you know what? I don't like them being off. I'm going to go grab all the 47s and 68s that I've got, and I'll match them. I feel more comfortable then, because I kind of know the answer to this question, and to be honest, if the resistances are off, yeah, the circuit's not going to behave perfectly. So yeah, I'll go get some resistors, match some resistors, and then the only test will be, you know, low value metal film versus carbon film. Is there any difference? All right, I grabbed the rest of what I've got. Just bring these here like this so that I've got them for reference. So, yep, these are all the correct value. $66, 66.1, 65.8. Well, there's like two really well matched pairs right there. That's hilarious. How's that for my luck? I mean, they're more than 1% matched, or at least 1%. So, what do I need? Two. Oh no, I need more than two each. Let's continue. $67.6, 66.7, 67.6. Yeah. $66.6 and 67.1. 65.9, 66.3, 66.7, 67.4. Wait, 66.7 is this. Oh, and that. Okay, cool. So that. All right, let's just get that sorted first before I get everything mixed up and confusing. I'll get this guy. I think it goes in there. 66.7 it is. Yeah, it's that one. Oh, my sponge is dry. Alright, I'm just going to go get some water for my sponge. Don't worry, I'm not going very far. I have this guy in here, especially for this purpose. Obviously, it's no good for washing and cleaning the actual sponge every so often, but certainly is handy for topping it up once or twice a day. Alright. I should have thought about this in the first place. I'm just so used to using high quality 1% resistors that are actually 1% or better that I've just gotten so used to not having to look. You know, the only time the 1% resistors I've got are that decent. The only time I'm really looking at resistors is if I'm doing some sort of precision circuit. And I'll give you a little example quickly. So these are some high precision resistors for power supply shunts, current shunts. These are Dale, I forgot what resistance they are. We can take a look. I think they're 10k. Yeah, that's right, they're 10 kilo ohm. These are 0.1%. And then I also have these, which are also Dale. These are the WSR2 series. These are 0.05 ohms. These are 1%. So nothing special. Those ones, they're just a small form factor for SMD sort of stuff. But yeah, so that's what I've gotten used to, is 1% everywhere, and I only order precision where I need it. But now, I'm using these 5% carbons. I've got to actually be mindful of their value. So, yeah, don't get too used to using metal film resistors or high tolerance resistors, should I say, because you can forget when you're using the normal ones that they might be off. Although you probably won't be using lower tolerance resistors in a high tolerance circuit anyway, so. I guess it just depends what you're doing. But I mean, I'm not going to go and spend extra money for carbon film high precision resistors when I can just match them out of what I've got, right? That's just bonkers. Alright, so I'll get this end of this board done first as well. Well, there's no point in changing both if we don't need to, right? Let's see what we've got. 67.6, 67.7. We don't need to change anything on this board. This is perfect. One board sorted. Okay, well, that went quicker than expected. So what are we working with on this board again? Can we even just swap the resistors? 66.4, 66.56. That's fine. So is it just here? 66.4, 65.8. Sixty-seven four, 67.1. Looks like we're going with, oh, we've got two that are matched already. Okay, it is what it is. What are our matched ones? 67.6. 67.6. You can't argue with that. The amount of effort I put into this amp, it would just be stupid to have an ohm off on one side to the other, you know what I mean? Yes, I know, I should have done this earlier. I'm not going to lie, look, I should have put planning into this project. I didn't plan it at all. You know, it's a project that I started on a few years ago, and just sort of, it faded away and never got completed. And then I just thought I'd pick it back up. And honestly, when I started this, I don't know, a month ago or whatever, I was just planning on building still 4 250 watt channels, but just sort of, you know, nothing special, something to run maybe subwoofers or something like that. And then I got the audio file itch back in me as I started building it, and I don't know, I just got carried away. And then the problem was, once I'd started replacing some parts, then I started looking at the other parts going, well, they don't belong there now, you know, so which is why I have ordered even more stuff to change. But at least I have everything to start, you know, getting it all sorted and up and running for now. the things that I have got coming are just upgrades, not you know, going to stop it from functioning. Also, you know, some of the things I'm going to be putting in it might not even make any noticeable difference. A lot of the audiophile industry is just wanky bullshit, but that's the way it is. I can't say I'm for it. I can't say I'm against it. I mean, I kind of like building fancy amps, but at the same time, where I am against it is the price people charge. So, yeah. Alright. What do we got on this side? 666. 663. I knew one of them was exactly the same. Yeah, I'll take that off and I'll put the 663 on there because it's exactly the same. You know what's going to happen now? Now I'm going to want all of them bang on. You know what, screw it. Let's see if we can. Why not? Might end up actually wasting less resistors that way if I carefully go through them all. I don't know if that makes sense or not. You'll see what I'm saying. I mean, this is just a hobby for me at the moment, so it's fine if I play around. 60, that's off by 0.1 of an ohm. These are bang on. What? Is it still hot? That's not still hot. Wait, what? What's going on? That's not dodgy, is it? No. Well, that's off by 0.2 of an ohm. Alright, I'm happy with that. 0.2, 0.3 of an ohm. Is this the same? 67.6. Yep. 66.8. 66.7. Alright, yeah, I'm happy with that. That's fine. Okay, I'll put the rest of these back away then. Not now, I'm just going to put them off to the side because you guys are here. Alright, let's see what we've got for the 47s on top. Now, being a lower value, these I'm going to want to match even more critically. Because mathematically speaking, tolerance is going to come down to a bigger number, if you know what I'm trying to say. 46.6. 46.5, I don't need to touch that. 46.8. 46.4. 46.9. 46.7. And 46.3. All right, that 46.3, let's see if we've got something close to 46.7. Oh God, which one was it? 46.8, 46.3. 46.7, I'll take that. So that one can get swapped out for this. Yeah, I'll be happy if they're just within 0.2 of an ohm. That's fine. I think this is going to work out to 1% or 0.1% tolerance even. It's going to be down there. Probably only 1% because they're lower values, so mathematically it's got to be, I don't know, my maths is so freaking poor, I wouldn't try and calculate it. But yeah, this is at least much better than 1% now, obviously. Because, I mean, at 46, 47 ohms, basically half an ohm would be about 1%. I mean, these are matched at 0.1, so they're going to be, what, this is, what, 0.5%? Yeah, that's more than fine. That's great. They're probably 0.4, 0.3. Like, I just can't do the exact maths on it, you know. I wouldn't be surprised if it's something like 0.35% tolerance, like the way I've got these matched. So, yeah, that's fine. The transistors aren't exactly matched. They're almost perfectly matched. They got the same VBE, but they've got HFE differences of 1 or 2. Nothing much, but, you know. As long as they're fairly closely matched, I've found that comparator circuits just work, you know. So, the ones on this side were fine, weren't they? 46.5, 46.6, wasn't it? Yep, 46.5. Sorry, I just realised you guys couldn't see the screen. So we've got 46.6, 46.7. All right, one more board to check resistors on. That didn't take too long now, did it? And that's the thing, a little bit of extra work goes a long way. That's why I don't mind doing these things. 46.5, hold on, 46.5, 46.2. Yeah, I'll change one of those. Let's just see what we've got here. 46.5, 46. Okay, I don't need to worry about that side. This one's over my 0.2 limit, so I'm going to swap one of them. I know a lot of you are probably sitting here laughing, but good. 46.6, 46.2, 46.7. That is good enough. Like I said, I'm not going for perfection, but I'm going for close to it. Oh goodness, I'll just leave the multimeter there so I can just double check that the heat hasn't damaged the resistor in some way. You know, just in case where the bit connects around the actual film itself, the metal cap, you know, just in case it doesn't have a defect and the heat brings it out and it has a high resistance connection or something. Obviously, if it wasn't a critical circuit, I wouldn't be worrying about it, but I am. I really want to see how well an amp can perform when you know, think about everything that's possible to think about and do everything that's possible to do, if that kind of makes sense. And I've forgotten which resistor I'm changing. 46.5, I think that's what we've got. Yep. All right. All right. That soldered in really quick, so it should be fine. Yep, that's just the heat. Yep, see? coming back up. All right, the resistors are matched. Yes, I know, haha, matching resistors. All right, what can I start on today? Cat hair removal, yes, that's always good. I think, oh, I remember, I've still got some resistors on the bottom. Oh, down here, 47, 47, 2.2 and 68. Why am I looking in the bag for resistors? 47, so 2.2 is going to be metal film because it's a higher resistance, 4 of them, yeah. 47 carbon film, low resistance, 4 of them, and 68, 4 of those. They'll also be carbon film. So these resistors aren't critical on being matched. It doesn't matter. If you took the 68 ohm resistor out that's in the emitter path and put a 47 ohm resistor in there, the front end is still going to teeter-totter to keep the output in the center as long as it's got a mid-reference point, if you get what I'm saying, which it does if it's built correctly. So that will be fine. I'll do the 47s first because they just go there. Oh yeah, still got to fold the legs back and over and cut them. Shit, I'm forgetting everything today. This is why I work at night time. It's like my brain's just sort of not very alert at daytime. And then when it comes in afternoon, I swear I'm like a rocket with this shit. It's just, It's something I'm trying to work on at the moment. I'm trying to reverse my sleeping patterns because I have a feeling that that's actually what it is. You know, you hear some people say, oh, I'm a night person, I'm a day person, I'm a morning person. I can't help but wonder if it's just sleeping patterns and health. So that's what I'm focusing on at the moment. I'll report back to you guys how I go, but I've already been trying to fix my sleep up now for seriously the better part of a month at least, and yeah, I've probably made about 3 hours of progress, which might sound like a lot, but when you consider that I was falling asleep at 5 to 6 a.m. I had done 7 o'clock, and now I'm getting to sleep at like 3:30, 4. It's really not, in my books, it's still not good enough. So I'll get there. But at the moment, I still don't feel like a morning/day person. But I have a feeling that that's sort of photosynthesis, sleep, you know, my hours, and the way my body's responding to it. And those of you that are laughing, I'll tell you, you'd be quite surprised how different things affect your health. Oh my god, I just realised I got someone important calling me and I won't see the phone call because my phone's recording. I'll be back in a sec. Alright, I got the rest of those 2.2k resistors, 47k resistors in whilst I was on the phone, and I've got the 2.2ks all trimmed up here. Actually, I forgot to trim one piece. Right, bit better. I'll get these tinned up and get these on the board, and then I'll get the 68 ohm ones on there. So the reason, again, that these are metal film is because it's a low current path, but it is a high gain area. So for that reason, sorry, I just need to think about this for a sec. I've got a cat sitting on my schematic. Excuse me. Thank you. 2.2k goes off the 47 ohm. So, okay, I know where they all go now. 2.2k's go here. And they go to the rail. Yes, to negative. What I'll do is I'll put one side on first, and then I'll stretch the resistor back out. I didn't realise these were for the rail, but they're actually the perfect size anyway, the way I've made them. I just bend them out. So that's great. I'll just get them all fitted first. Oh, just tapped my thumb with the soldering iron. Cool. This thing's coming along. Not too many components left now. Oh, actually, you know what? There's actually quite a few. Sorry, I got something in my throat. That's better. Alright, that's the 2.2s on that board. All right. Okay. I'm happy with that. So now I'll put these 68 ohm carbon films in. The reason I went with carbon film for the low value resistors is purely just to minimize inductance. The resistor value is so low that noise isn't going to be a problem, so I've gone for inductance. That's what I mean. It's kind of hard to explain because every single resistor in the circuit, I sort of came up with my own logic for why it should be what it should be. So it truly is a mix, as you can see. Anyway, this is going on the emitter of the It was a 2SC 3206. It's now something else. I'm starting to get pretty good at this. This always happens to me when I'm making something up in like a batch, like a lot of the same thing. But then when you don't do it for a while, you come back and do it again, you're all slow. That'll do. 2 of them. Should have my fan on. Something's wrong with my fan. I've only got it on the low speed, but it's making a funny sound. Oh. No way. It's not even turning. If what I think is happening, this is going to be absolutely freaking hilarious. So, oh, this is funny. So I've got these 2 plug packs underneath here. You can see one of them. And they're wired up to these, but they also run this little desk lamp and this fan. And there's another fan up there on the other end of it. But anyway, that's on the low speed. So that works on high speed. But not low. It's just making a ticking sound. I had a couple of 4700 microfarad capacitors on here, and I took them off the other day, put them back in the drawer, and now the fan's not working on low speed. That's just hilarious. I've got a funny feeling the caps in those power supplies are on the way out. And the reason I think this is so funny is because the other day when I put those caps back in the drawer, I literally said to myself, wouldn't it be funny if everything stopped working because the caps in the power supplies have gone? Haha. That's actually what's happened. I shouldn't think these things. I think I jinxed myself. But there again, if my thought power has that much effect over what's going to happen, let me think that this amp's going to be the best thing in the world. What am I doing? I'll turn that off. I have to sort that out later. Well, there's a couple of 68 ohm resistors. I shall solder them down on the other end. I've been putting some thought into what I'm going to do about the ground rail. I think I'm going to cut it up. I'm not too sure. I might leave it all one piece and then run wires back to one point to give it multiple points to bring it into a star. Or I might cut it into sections, so like put a cut there and a cut there and a cut there and a cut there, so that there's a little ground strip either side of this, and every individual piece of strip will go back to star ground. I think I might actually do that. Again, it might seem like overkill, but why not? I've got the provision to do it because of the way I've laid the board out. Might as well go for it. It's not going to hurt anything. It's only going to make it better. I mean, you can only make your ground better, not worse. You can make it worse. You know what I'm saying. improving your ground is a good thing. Unless you're creating a ground loop, then it's not. But you know what I'm saying. Yeah, and go back to making these up the way I was doing it before. I've been trying it different ways to see if I can do it quicker, but that was just slow. Alright, the solder's already here. I've just got 10 resistors. Alright, that's good. I'll solder these in. Alright, what next? It's amazing how packed the board already looks, and yet I still have, no joke, all of this. This is what you call an intense build. Alright, these aren't going to take up much space. Let's see if I'm forgetting anything else back in this area, because I do see some random pads in different places. Now, I know that's my base terminal, and I know this is an option to take the compensation to ground. That goes to the negative rail. Okay, that was because there was a resistor there before. Alright, so that's all good. That's for the optional pots. Okay, input, ground. Do I want all separate grounding? I don't know. I'll work that out when I get to it anyway. Okay, so we're going to be missing resistors up the top here. 330 ohms. You know what I've really screwed up on? It's okay, because I can go back and watch my video, which is what I'm going to have to do, but I can't remember with a red LED, the transistor I'm using, what current a 330 ohm resistor yields. I think it was 4 milliamps. It might have been 6. I think it was 4. But yeah, I can't remember. That's really not good. Yeah, that's all right. I know it's in the video if I go back and watch my video, so I can work that out. I just need to know, because I need especially the VAS current source. The input current source, I will probably leave it at 4 milliamps for now. Yeah, the VAS I might move up to 6, 8. I'm not too sure. Obviously, the bias will have to be adjusted at the same time, but the point is, I need to be able to do it. So, yeah, I definitely need to work out what current 330 ohms was yielding. Well, I'm going to put these diodes in. These go looking up towards the NPN side, if that sort of makes sense. The NPN side's the top side, so they're going to be pointing that way, and they go across. Well, what components have I got there? I've got 4.7 diode. I still don't know if I want a 10k resistor there or not. That's something I wanted to experiment with. I think I will, to start off with. Let me just have a look in my book and see what values I've put further up. That's about 820 ohm. That's about 200 ohms. Yeah, 10k. That's an order of magnitude bigger again. Yeah, okay, so do I have room? That's 3 components. The diode string attaches externally. So yeah, I've got room. Alright, well, one thing I do need to bear in mind is the size of the capacitor, and especially the fact that I've got even bigger ones coming. I ideally do want the capacitor kind of close to the transistors. I'll put the capacitor in the middle. You know what, I'm going to put it at the end. I think it should be at the end, so everything else has got to go past it. But again, if I wasn't trying to build a really high-end amp, you wouldn't really care about what order these components go in. The thing is, once you get down to fiddling with the sort of crap I'm fiddling with, the improvements that you might yield from each change or modification you make might be so small that you can't even measure them with good equipment, let alone hear them. But the thing is, when you add 100 of these things together, little mods and upgrades, then it all of a sudden adds together and does become measurable. So, you know, depending on how you think about it, it's either a waste of time or not a waste of time. To me, it's not a waste of time because, you know, if I can build something that's really high end, instead of spending, say, $50,000 on one, it's worth my time. Not happy about that. I need to get a little bit more solder in there. Alright, that'll be fine. So MKS for now. Soon to come MKP. I'm hoping that these MKPs I've got are sort of in between this size and those yellow ones I showed you guys. I'm not going to bother getting them out again. So I found one online that had its dimensions actually written, and it was smaller than those yellow ones that I got, which are smaller than the MKP4s that I have. And then I came across this other capacitor, and it looks like it's the same sort of cap. It's an X2 cap for MKP. And it looks like it's the same small kind of packaging as the other one, but its dimensions weren't advertised. Anyway, I've taken my luck on it, so we'll see. Nope. These are a bit of a pain to solder down. Because I've made them so laid to the board, it's very hard to get the iron in. And of course you don't want to melt them, so you got to be really careful. Alright, I got it, but that is only two. There's still another two, and I still have to fit the components either side. Fuck. I put that in the wrong spot. You gotta be shitting me. I hate taking heat to capacitors, especially twice in a row. God. I'm just going to wait a sec because it's going to, start getting really hot inside if I just keep hammering it with heat. What am I going to do with that ugly blob of solder then? I don't need that much solder. Try and get it over here. Whatever. Good enough. Alright, I'm just going to wait a couple of seconds again for that to cool down, because it'll get red hot inside if I don't. I'm going to flow some more solder in there. Oops. Alright, that is well and truly soldered down. Just chuck that over there for now. Same thing again. I just realised, is that why I had trouble soldering them down? I forgot to tin them, didn't I? Or did I? I can't remember. I don't think I did. That's probably why they didn't want to solder down properly. Oh well. Cut that one really short. It fits on this side, however. Hopefully the other one will fit on the other side. Oh yeah. Cool. Got lucky there. I shouldn't have said that. I really shouldn't have said that. I'm not happy with the amount of pin that's on one pad, on one of these caps. I might be happy after I get this bit of solder in here. Yeah, okay. That's alright. Alright. I'll put the diodes next and the resistor last. Actually, no, what am I saying? I'll put the resistor next and the diodes last. Yeah. So, there should be 10k resistors in here. Oh, there is 10k resistors in here, but they are carbon film. Let me think about this. I don't know what I want to put there. Let me stop and have a think. Alright, I'm going to go with carbon film. I've been thinking about it, and here's the thing. This stage of the circuit has no voltage gain, right? It's only got current gain. So whatever noise that these can make, it's not going to be amplified voltage-wise. And, I mean, it's probably just going to get shunted out by the capacitor that's across the resistor, to be honest with you. So I think, you know, something that's got a bit more inductance to it would have more of an effect here than something that's got a little bit of noise to it. I could be wrong, but, you know, this entire design is based off a theory, my theory. You know, that's where the testing comes in afterwards, is to change all of these things and see if there is a difference, and if there is a difference, which direction is the difference going in for what change, you know? Oh yes, there are going to be a lot of videos coming up on audio. I'm going to be one busy person. What am I saying? I'm already busy. That's those. We'll tin them and tin the pads. Oops. Oh, God. That's one resistor. That's another one. Talk about a huge project. I mean, admittedly, if I was using through-hole construction, it would probably be about twice as quick, but there is still a lot here. And, you know, because I've spent time going over components to match them and check out their parameters, and I've changed things when I've discovered better components exist and all that sort of jazz, probably still would have taken quite a bit of time. Alright, I'll take that. I think now I will put the diodes on. Yeah, that's what I'll do. So, as I was saying before, the diodes point up. Hey, this resistor bag's finally looking pretty empty. Wow, we're getting there. These diodes have got to point towards the NPN side, if that makes sense. Point away from the end. No, yeah, towards it. Yeah. So they've all got to face up with the board the right way around. I think I'm going to do these a bit different. Honestly, just purely for show. Nothing else. But I want the board to look cool. It's really not straight. I just cannot get the leads in the shape I want them for the life of me. Just make sure that fits. Yep, that's perfect. I've done it again. I've got to take a phone call. I keep forgetting I can't hear my phone ringing with the camera on. Alright, I ended up fitting those diodes off camera. I'm going to put the 330 ohm resistors on now. I'm not quite sure why I can't see them. Oh, there they are. 4, 8. Cool. Whoops. I just dropped resistors. Ah, bugger. Alright, I found the resistors. I'll just leave them there. The piles that small don't even need the bag now. Bag can join all the other bags. Alright, so these are for the current sources. These boards have been drop tested. Jeez, I don't know what's going on here. I'm getting messier and messier. Usually I get neater as I go along. Oops, still got 2 more. Oh, 3 more. Well, now 2 more. Okay, I think I'll end the video after I fit these resistors because it's probably over an hour already. It's amazing how long this stuff takes. Truthfully, I was only going to do one board at a time in the first place, but I know myself too well, and if I do one at a time, what will happen is the other one will be sitting there forever before it gets done, because I will lose motivation after sitting here repeatedly soldering stuff on the first board. So I thought, no, I'll do them both together. That way they both get done straight away, not one, 2 weeks later or something. I'm going to have to go get some food soon too, so it's a good thing that I'm ending the video now. It works out good for me and good for you. These aren't exactly my normal video format anyway. I mean, I just thought I'd just record some soldering work. Just, sometimes when I'm trying to fall asleep, I like to watch something that I'm not, worried if I don't pay good attention to it, because, like I might not be learning anything new or whatever the reason is, but I still like something to fall asleep to. Sometimes I might be working on something that doesn't take a lot of brain power, and I like to watch or listen to something in the background, So I thought I'd just film myself working away and upload it. And if people like watching that sort of thing, it's there, If you don't watch it. That's one thing you don't have to worry about with me, guys. I will always produce different types of content. I've got to be mindful of these transistors with the twisted legs. It's a bit annoying. Not a lot I can do. Sorry, you guys will be able to see what I'm doing in a sec. I'm just starting down this end first. I thought I was going to have clearance issues, but actually not. I'm quite comfortable. I still, of course, have to bend the resistors out a little bit further to get to the actual trace that they connect to, but that means they're only going to be even further away from those twisted transistor legs, so it's not going to be a problem. All right, let's bring them out over here. Alright, that's the current source resistance for one board. Cool. I was going to do this one first because I need to reflow the solder, not on the end I'm putting down to the board now, the other end. I don't want to come back and do this afterwards because I might forget. Alright. That's going to need a reflow as well. That one's good. All right. There we go. All right, I'm going to leave that here. No, you know what? I'll put a couple more things on because just looking at this, there's actually still quite a bit. I'll grab all these 10 nanofarad MKP4 caps. I'll get them on. Oh, I gotta stand up, take a walk, my back's getting sore. Alright, back to this. I'll probably just get these last 4 caps fitted and I'll leave the rest for the next video. That seems about the right amount for a video. That actually seems a little bit small, but when you add the resistors to it, I think it'll take a fair amount of time. So, I mean, to be honest with you, I haven't even done all of this on camera. There's been parts of this that I've done off camera, and so far I think I've already got like 3 hours of footage combined all up or something like that. So, yeah, there's probably at least another hour of work just there, getting all those leads bent to shape and soldering all the components down and double checking all my choices are correct, all that sort of thing, you know. Like I said, these videos aren't my normal style video, and I will put in the description for this video that it's just more soldering components on boards, basically. As I did. Hey, don't eat that. What are you doing? Stop it. Down. Good girl. Oh, I forgot what I was saying. Anyway. I should get these mounted and I'll end the video here. Tell you what, I haven't been feeling it today. I don't know if it comes across on camera, but I just feel slow and unmotivated, I think the word is. It's funny because like I've got the motivation to do this because I really want to get this amp done. But at the same time, I just can't be asked today. It's weird. Earlier on, I was thinking, oh, it's just because I'm not really a morning person. Well, not at the moment anyway. But no, it's later on now and I'm still not amped. No pun intended. Bit of a tight squeeze. The legs almost don't reach the pad. Nice big glob of solder on it. It's got plenty of surface area now. I don't care if they're not perfectly straight, I just don't want them right up next to each other. Capacitors capacitively coupling. That sounds funny. I'm just going to angle them out a little bit like that so that there's no crosstalk between the two, because one's from one channel and one's from the other channel. I still got to put the resistors in behind them. Oh well. Because they're going up long ways, like standing up, it'll be easy to get them in, even with these there. If they were standing down like that BAT 46 diode that I've got in there, yeah, that wouldn't be so good. Why on earth don't I have more space? That's a bit better. Alright, so the resistors are going to be the 430 ohm. Only these funny looking ones. Funny as in the colours. It's just, I think 430 ohms just colours that I don't see often, so I find it a little bit odd, if that makes sense. You know, usually you see 10Ks and 1Ks and 100 ohms and 47 ohms, and it's just a lot more commonly used values than 430. It's not something that you find a lot. I'll end the video after I've put these on, because that completes this little section I'm doing in the middle. I've still got a couple of components to fit on the outside of it and all the stuff that goes around the outside. And I've still got quite a few resistors here. There's 100 ohms, there's 68 ohms, 10 ohms and 47 ohms. So I've either grabbed too many resistors or there's a little bit of stuff missing here. 47s are there. I can only think about where the Oh, that's alright. I got 100 ohm resistors on the base. Okay, yep. So the 100 ohm resistors go in there. Let's just see if I've done this right. We've got, yep, 47. Should be what? 1, 2, 3, 4. And I just had another set of 47s. So it's the 47s and 10s. Should have more, because hold on, I'm 47s. Is it just 2 10s? Yeah, okay, it is. It's 2 10s. Okay, so that's all right. And then the 100s, there's going to be, how many bases? 1, 2, 3, 4, 5, 6, 7, 8. Should be 8. Yep, 800s. And I've still got 468 ohm resistors here. I am not quite sure what they're for. That's kind of concerning me, because they're probably important for something. 68. I think I actually do just have extra resistors. I'm just not seeing any more 68s other than the ones that I've already fitted on the bottom of the current mirrors and the emitter of the VAS transistor. And I know there's no 68 ohm resistors further up the circuit. I've got a funny feeling that I didn't need to grab those and I just miscounted. Let's hope so. That should be a link to the rail. Yeah, I can't see anywhere that there should be 68 ohm resistors. I'm just going to put these back in the drawer behind me. Hopefully I'm right. And I'll just continue with these. So yeah, not much left to do after these. I'll get these done and I'll wrap this video up, and then there'll probably be one more video about an hour long of soldering. And then we'll be back to doing interesting stuff, putting it all together, working out the case. Although it's not going to be installed properly in the case for quite some time. It's just sort of going to be laid in there. I'll probably drill holes for volume controls and RCA jacks and all that sort of stuff, and mount that stuff. But I don't know. The thing is, because I've got so much testing and work to do on it, it's going to be coming in and out. So I don't want to sort of fully mount it yet, you know. But at the same time, whilst I'm working on it and testing it, I want to have it in my living room set up with different subs and speakers and crossovers and EQs. So I need it sort of in something just to carry it around and to stop the cats from getting at it, but it doesn't need to be screwed in and all that sort of stuff yet. And I've actually still got quite a bit of work to do in terms of mounting. I mean, like the heatsink modules, the power modules, whatever you want to call them. I need to get some little right angle brackets that will sit here to support this board, and I don't know how I'm going to do the top board. I I might just leave it, honestly. There's not really any weight on it. Although I am sort of worried with thermal cycling and vibration over the years that these will snap. But you know what? No, I will leave it because that's something that's going to get redone. Because, you know, this is that bias string was a solution I came up with years ago before I even thought about the fact that the larger junctions could have bigger switching noise because of the larger capacitance. So, yeah, because that's all going to get changed, I think I'll just leave it as it is for now. I might not even bracket the bottom board because I've got a really good feeling. There's just too many things I don't like about those bottom boards, and if I decide, I'm going to put 200-watt devices in it or something, or just different transistors, I'm going to make new boards. I'm not going to deal with that headache again. The headache that I created, yes, I know. Anyway, we'll see how it goes. I mean, at the moment, I don't even know if it's going to work or if it's still got that problem where it doesn't want to go over 10 volts of gain. I'm pretty sure that was just current limiting and inductance of long cables and breadboard traces and fake transistors and just a myriad of different issues. So it should work, but we'll see. Because that's something I never did. That's what I was up to doing, was basically I needed to work out how much front end current. Well, I worked that out. I want to have 5 milliamps going through the front end. I will work out what value resistor that is and fit that. That's not done yet. But the VAS, I want to work out how much current's required to, you know, have enough drive for what I need, and then just give it like, I don't know, maybe a milliamp or two more just for headroom and, you know, be done with it. And I was up to doing that before and I couldn't complete it because, well, I couldn't get the gain to go up without some strange things happening. These resistors will end up getting changed. These, I'm pretty sure, yeah, they're magnetic. These are the only resistors that I didn't have in stock 430 ohm high quality ones, so I used cheap Chinese ones that I've got. I'll wait until all of those parts that I've just arrived, capacitors and everything, arrive, and I'll change, you know, everything all at once. It'll just be done in one video. All right, they're all tinned. I really should have put them in first, although actually, no, then I wouldn't have been able to get to the capacitors. No matter which way you try and do this, it would have been tight. It's not bad. I mean, as you can see, I'm getting to the hardest pads are the ones in the middle behind those two little 10 nanofarad caps, and I've gotten all 8 of them. There we go. Alright, Alright, this is the last little bit I'm gonna video of me soldering components on this board. I've already got some of these resistors on just then off camera. And then I'm gonna end this video because it's getting quite long. Alright, I'll get them soldered in. Good beauty. Okay, well, that's it for now. I need a break too, because all I've done for hours is put components on a board and solder them and make legs up. But anyway, that's where we're up to so far. It's getting there. It's actually looking quite nice if you ask me. I am impressed. Alright, if you like what you're watching, give us a thumbs up and subscribe. I'm going to end the video here, and I will take a little break and probably come back pretty soon and get the last bit done, because I am very eager to get this up and running. Anyway, I'll see you all soon. Take care now.